Presentation 25, WNY-STEM, Buffalo-Niagara, New York, Mission 12 Flight Experiment.
Okay, good afternoon. We're all recently graduated from Wellsville High School in Wellsville, New York, and we are part of the Western New York STEM community. I'm Shannon Nye, this is Tyler Watson, Trinity Rulo, Brandon Bailey, David Graham, and Nichelle Danheim. And our educator is Mr. Ross Munson. Our experiment title is The Effect of Ascorbic Acid on the Rate of Regeneration in Microgravity. Clicker.
We came up with an experiment that could be performed aboard the International Space Station. The constraints included an 8.4 milliliter tube with 2 clamps and a stopper at each end. We decided on the Type 3 FME with 3 different compartments and 2 clamps.
So the first volume of our tube contains 1.8 milliliters of a solution of ascorbic acid dissolved in water. Ascorbic acid, or as more commonly known, vitamin C, is a water-soluble vitamin that helps with the synthesis of collagens. So collagens are structural proteins that are found in the connective tissues of animals. So in mammals, such as humans, collagens make up 25 to 35% of the whole body protein content. And then in our center volume, we have 5 milliliters of water, which contain with it 3 planarian flatworms that have been cut into 3 segments, a head, a body, and a tail section. So the first issue that we ran into with our experiment was not only finding an organism that we could demonstrate that we could test regeneration on, but also one that would be able to survive in space and fit in our tube. So we ended up settling on these tiny little flatworms called planarian worms, and the brown variety that we went with are kind of like the gold standard when it comes to testing regeneration experiments. And our final volume contains 1.6 milliliters of 10% neutral buffered formalin as a fixative, and it doesn't stay on. But where was I? Oh, so on the first day that our tube is aboard the International Space Station, the first clamp will be unclamped, and our ascorbic acid mixture will be mixed in with our planarian worms to begin the experiment. And then 2 weeks before undock, the last clamp will be unclamped, and the formalin, which is a formaldehyde-based fixative, will fit our experiment in place so that we can actually analyze the worms when they get back to Earth. Since we have 2 independent variables with our experiment, both microgravity and the ascorbic acid, we have 2 ground control experiments, both of which without the microgravity, of course, and then one without the ascorbic acid, so that we can actually isolate which variable has affected the rate of regeneration in these worms. Another issue that we ran into was actually preventing the worms from beginning to, since we cut them up here and then there's a couple weeks between the time we ship them off and them actually being sent to space, we encountered an issue with the fact that we were worried they might start regenerating before they actually got to space. But through some studies we had found and our own research, we had concluded that colder temperatures, such as just refrigerating the worms, will actually delay their regeneration until they are in warmer temperatures again. So from the time that our tube left us until it got to rats and then put onto the rocket, it was refrigerated the whole time to ensure that the experiment would not start until our worms were in microgravity.
So when we got together as a group, we all kind of agreed that we wanted to look towards the future, and that since research done by NASA has shown that long-term exposure to microgravity can have negative effects such as the loss of bone mass and muscular atrophy. So our hope is that our experiment and vitamin C will help to counteract those effects that, like Tyler said, vitamin C helps with the synthesis of collagens. So if we can kind of work towards that, we can help to counteract the effects of muscular atrophy and the loss of bone mass and achieve our goal of long-term space travel.
We have run several preliminary experiments here on Earth that validate our experiment. by showing that when exposed to ascorbic acid, the planarian regenerate faster. So as you probably heard, the rocket carrying our experiment just launched this morning, so we don't have any current data to report. But once we get the tube back, we'll be able to determine the rate of regeneration using an arbitrary point system, which we developed based on the different stages that the planarian go through during regeneration. So we will examine each segment under a microscope, and we'll assign it a numerical value based on the point system. We'll then compare the points of the flight experiment with the ground truth experiment and further analyze the results from there.
We would like to thank all of the local, community, and national organizations. Locals listed mainly on the left, and national and community are listed mainly on the right. And we would like to highlight schools within our local community, like Alfred State College and Alfred University, and our high school as well, Wellsville, for morally and financially supporting us all.
Do we have any questions for this team?
Okay, so the vitamin C, I'm going to call it stuff for lack of a better word, does that have to be topical, or are you looking at implications for ingestion? And does oxygen need to be present if it's topical?
Well, we had never really considered the topical applications of it. We were more looking at, since we will see astronauts someday having to deal with the effects of long-term exposure to microgravity, we are thinking that they're already up there taking vitamin supplements, that we could possibly more focus on the vitamin C to help counteract some of the negative health effects, such as the muscle atrophy, in which the additional synthesis of collagens could potentially prove valuable to counteracting those effects of microgravity.
Okay, thank you.